waves.
It's more interesting. Waves.
It's more interesting than what? Exactly.
Like
It's not that big chapter of space. It's not that big.
It's not too difficult.
It's not big wavelength and these things.
I want to make this up a little bit. There we go. There. It might be helpful to drop things here. Yes, you move down to here and you move across if you need to. I can't see the people behind you when you're sitting at the corner. So just so you're clear, so far we finished these two. The first one was mechanics, and then the second one was electricity, and then the third one will be waves. So what I mean by waves are things like this, for example. So you could have like a sound wave, light wave, stuff like this.
Voice wave.
Yeah. Now in the exam you'll have in a few weeks, you have section A, and this will equal 12 questions, and you must do all of them. Okay. Now because it's 12, what'll happen is you'll get 4 from this, 4 from this, and 4 from this. Okay? And then in section B, you have 3 questions, but you only need to do 2 of them. So you'll have from B, 1 here, 1 here, and 1 here. You understand? Yeah? So it doesn't matter, you have to learn everything because it'll all be in section A, 444. But for section B you can pick 2. And which 2 you pick depends on which one you don't like. So if you don't like electricity, then you do the other 2. You know? Yeah, whatever you prefer. This, I mean, the difference, you know the difference between them. A lot of students don't like waves because, I don't know why, but a lot of students don't like waves. Most people pick the first 2. Even though I don't think this one is so bad. I don't know why. A lot of people don't like this one and they pick these 2. Okay? But anyways, my point is, you have to revise everything because section A has everything in it. But at least in section B you can pick your best 2. Whichever 2 are your best 2. Yeah? Yeah. So we're going to have a look at waves now. Alright.
Is there a section C?
No. Just A and B. Okay. You got this for the test? Oh yeah, and I should also say the time is it's 2 hours for the test. Plus 10 minutes for reading. And yes, you do get the formula book.
10 minutes for.
Huh?
10 minutes for.
Say again?
Read the questions.
100. 10 minutes to read the questions, yeah. You can't write in this time. Yeah?
The formula book is
Mhm.
the same.
Yeah.
It's just
Yeah, the same as what I gave you. Same formula book. Yeah?
that's good.
Okay. Any other questions about the test? No? No? We'll talk about the maths test in maths class, okay?
We have no question. You can give a question, sir.
Huh?
We have no question. You can give a question.
Alright. Okay. We shall start the waves then. PDF. So, new chapter, waves. Opening. There we go. Wave motion. Got that?
Yeah.
Yeah? Okay. Right. So we'll look at different types of waves and then an equation. So there are two types of waves. The first type is called transverse, also called an S wave, and the second type is called longitudinal, also called a P wave. Why? Because you'll see in a moment, but its shape is like an S. Yeah.
Write that down.
Oh my goodness, yes. Definitely.
The first one is safe, not a wave.
They're both waves. They're both waves. They're two different types of waves. Oh yeah, sorry, of course, S waves, not saves. My goodness, I didn't even notice that. Yeah, S waves. Yes, that's totally a typo. S waves, not saves.
Superman saves the process.
Okay, have we got these two? Yeah. Yeah, well, that's a wave, not saves. Okay. So now the definition of each. So before you write down the definition, you'll get a picture in a minute that explains it. Okay, so this is just the definition. A transverse wave is a moving wave that's made up of oscillations happening perpendicular to the direction of energy transfer. So just before you write that down, a very quick picture of what this wave looks like. Whoops. Transverse wave. Whoops, that's not quite what I wanted. What's happening is it's moving to the right, but as it moves to the right, it's vibrating up and down. Like this.
It's moving to the right.
Yeah. Come on, yes, come on. What's that?
Why do you not moving to the right side?
Oh, because I said it is. Yeah. In other words, these movements up and down are perpendicular to where the wave is going. It's a wave. So that's the first one. Just this so far. Don't worry.
What's the first? What's the pattern?
Waves. Wave motion. Oh, just wave movement. And Grace, that should say wave. S wave, P wave. Huh? this is S wave, transverse. This is the picture here. It's a wave like this. S wave. Okay. Yep, the next one. So the next wave, longitudinal or P wave. The definition is a bit longer. In a longitudinal wave, the particles do not move with the wave. The particle movement is parallel to the direction of the wave. So there's a lot there, but let me draw it. So for this type of wave, it's difficult to draw, but I'll try here.
Don't they have the same distance?
No. So the wave is moving to the right, but the vibration is happening parallel, not perpendicular. So notice the difference between this one. This is moving up and down as it moves to the right, so it's perpendicular. But these ones here are parallel. So the wave is moving, it's kind of vibrating like this. So the first wave is going up and down, like this, up, down, up, down, up, down, up, down. But the second wave is kind of vibrating along like this.
There's an angle there, right?
An angle?
Yeah.
An angle where?
And vibration like this. See the wave now? Like this.
I have a little curve.
Yeah, it's curved.
Oh, that's because I can't draw in 3 dimensions.
Oh,
Yeah.
okay.
So it's just moving along like this. Okay. There's a verb in English you all know. You all know the verb move.
Yeah.
You know, move here to here. Yes. But for waves, we don't use this verb. We use a different verb. Which I know it seems very annoying. But you see this word here? Propagate. Propagation. The verb is propagate. Propagate means move.
Only physics?
Only physics and only waves.
Oh.
Yeah. So here we can say move the cup from here to here.
Propagate the wave from here to here.
The wave propagates. The wave doesn't move. It propagates. This is just the English thing.
So an exam kan je het move.
You might get more marks now. You might get full marks if you use propagate. You might not get full marks if we don't use this verb. Now, there's not many definitions in waves. In fact, there's really only like 4 definitions in the chapter, 4 or 5 definitions in the chapter. You got that?
No.
Not yet. Which bus were you on, Amanda? 9, 16 or 122?
What?
Which bus were you on?
1, 2, 3.
1, 2, 3.
Hmm.
1 to 2.
Slowly.
Slowly, very slowly.
Yeah.
Okay, go on.
Yeah.
Not yet.
Last line.
Last line, okay. Amanda, can you wake up KJ? I think he's asleep. No, he's not awake. You got a sleepy look about you. Is that a letter or on your cap? Team Rocket? Does it mean anything? It can be for resistance. Alright, can we go on?
Yes.
Yep, alright. So there's a picture here that will help with the two types of waves. Oops. Let me load in. Loading. Okay. There we go. So the P waves, they're vibrating left and right. Do you see that?
Yeah.
And then they move across to the end. Whereas S waves, they're vibrating up and down. That's the key difference. So here, this is parallel to the movement, whereas this one is perpendicular to the movement.
Where's this on Elvis? Where can we see the first one, the second one?
Oh, there. You stick a spring against the wall,
Ah,
and this is a rope against the wall. We'll do examples of these types of waves in a moment, but this should help you picture the difference between P waves and S waves. And you can see why this is called an S, because of its shape. Huh? This is more of a Z? What are you talking about? It's an S. That's more of an S than a Z. And this one here is a P wave. P for progress. You don't have to draw this, but it should help you to see the difference between the two. Yeah? Longitudinal, transverse. P's and S waves. Okay, can I go on? Yep.
yeah.
Right, so waves, different parts of the waves have different names. So we've seen this word before, amplitude. What does amplitude mean? It's like the maximum distance, okay? The wavelength is the distance for one wave, so like from here to here. Crest or peak means top.
Peak.
Yeah, I think I normally say peak, but really maybe we should say crest. Huh?
So if you only use crest in waves.
No. You can say peak if you want. Like when you said peak, I know exactly what you mean. Peak is a synonym for crest. And then you have trough here, which is like minimum. Distance is on the horizontal, and then for us, displacement is on the vertical. So this is how far the wave has moved, and this is how much it's been displaced vertically as it's moving. So if you imagine like a little person sitting here, this is their displacement going up and down, up and down. Although if they're sitting here, they would end up moving to the right. Anyways, don't worry too much about that. I just want the names right now, okay? So make sure you write down all these names. Okay, crest, trough, amplitude, wavelength, displacement, and distance. Hey, that mean I'm in a different room?
Yes, you are.
Yes, I remember now. I am. Oops. I think I'm in 8401. Guys, did you get some timetable saying we're in a different room now?
I don't have a timetable.
Alright, well, where's Matthew? He's going to be here soon and he's going to be so angry.
It's coming.
Oh, that's worse. Alright, let's get out of here.
Oh yeah.
Let's get out of here. Quickly. My goodness.
Yes, change everything. Good time.
Yes, good time indeed. Okay.
Turn on the light.
Oh no, it's okay actually. We don't need to.
No.
Not necessary. Okay. Continuing. I believe I'm still recording. Nice. No problems. Alright, you're writing these names down. Got these names? Can you see okay?
Yes.
Yes? Maybe. Yeah, I don't need to have it so zoomed. That's a bit better. No, it's all or nothing. There's no two switches. Well, if you need the light, do you need the light up?
Yeah. Because I forgot my glasses. I'm a forgetful guy.
You're so forgetful. Can I continue? Yes? Okay. Maybe, yeah. Yemi, do you mind? Okay, that's a bit better. Yeah. So just as these are the words we're looking at. So displacement, how far the particle is displaced. But you know displacement already. Amplitude, that's the maximum displacement. You also know this word. Now wavelength is a new word, but you can guess its meaning, the length of a wave, usually from peak to peak, for example. Yeah. Period, you know period. It's the time for one cycle.
One circle.
Yeah. Now phase difference, this is...
We are right now?
Yes.
No.
Please. Phase difference is a new word. So I'll explain phase difference. I need two different colours. So you have one wave, and then later there's another wave. And it's nearly the same except there's a small distance between them. This is called the phase difference. And we usually measure it in seconds. So for example, you have one wave and then 1 second later you get the other wave, which means it'll be a little bit behind. So here, for example, could be 1 second time difference.
The time is equal between the two, all of them, right?
They're all supposed to be the same wave, yeah. So phase difference is like the time difference between the two waves. The time difference between the peaks of the two different waves moving together. Although, yeah. Okay, there's a few more. I'll just wait for you to get these.
Moving together or propagating together.
Yeah, I was keeping English too simple here, but it'd be propagating together. Yeah. No bonus points for you. KJ already said that.
Next one is correct for myself.
It's not that moving is wrong. It's just that propagation makes you sound smarter. Yeah. Although it means moving. I wouldn't quite say it's jargon, but it's not too far away from it. Yeah. Okay. All right. Some more terms. The next one, don't worry, they're just going to add to this, not a new slide. The next one is frequency. Now you all remember frequency? It's how many cycles per second. So again, how many cycles are completed in 1 second? What's the unit for frequency? Hertz. So you know frequency already. And speed, well, you definitely know speed. How fast the wave is moving or propagating. Okay.
No.
No. Yeah. Yeah. Which one are you writing, Grace?
Last one.
Typing, which one are you writing? Last one, okay. Yes, Tekken? Yep, okay. So firstly, remember that you still have this equation. This is still true. Frequency equals 1 over the time. Do you remember where did we see this equation? Yeah, what? Yeah, we don't call it cycle motion, but I know what you mean. Circular motion and simple harmonic motion. Anyways, here's your new equation for today called the wave equation. And the V is the speed, the F is the frequency, and this symbol is called lambda, and it's the wavelength. Yeah, Greek letter. Lambda.
Okay, remember.
Yeah, I suppose so. I always think more like lamb. This here is lambda, lamb. And it means the length from the length of one wave. Yeah, the wavelength.
Is it in meters?
Oh yes, of course. Yeah, meter, hertz, and meters per second. The normal units here. Yeah, got that? Yeah. Okay. So here are some examples of transverse waves. Light, light, ocean, and waves in a guitar string. So I'll just draw those. I don't have yellow. Here's my blue sun. So light is one. What was my second one? My second example was ocean waves. And so I'll do my ocean in red. And look here, I'll put a little boat on it.
There's a ship over there.
Ocean waves and guitar. Why am I even trying to draw this? Yeah, that's a good question. No, don't pretend you know. This is a ridiculous picture. Huh?
Guitar is bigger than
Yes, and both as well. A guitar, if we're playing music. So the strings on it, when you pull the string, it's also a transverse wave. Longitudinal waves, examples are sound waves, underwater waves, and waves in a spring. So, for example, sound wave. So the waves coming out here, these are longitudinal waves. Also, interesting, I know the waves on the top I said were transverse, but the waves under the water, where's my colours gone? There's my fish. The waves underwater, like if this fish is swimming, these are, yeah, no, it's a different thing. When the fish moves in the water, the waves it makes behind its tail, these are longitudinal. And then the last one, what was my other one? Oh yeah, the spring. So if you had the spring moving up and down, it makes a wave here that moves up and down the spring.
Fastest one? The sun,
light is the fastest one, but we'll get to that in the next lesson. Yes. Got that? Yes? Not yet? I see you started to draw my pictures and then decided, no, these are ridiculous pictures, I won't draw them. Okay. Next. Yes? Okay. Next now is, I think, an example question. Okay, so just one example to do. So write this question down. this? So once you write it down, again, read it again, and try and picture the problem before I draw it. Yes, dock is like pier. It's where you get your boat. It's where you keep your boat. Where you keep your boat at night. In the harbour.
At night.
At night, you know where you tie the boat. You tie the boat onto. No, I'll draw it.
Oh, I got it.
Here. So what's happening here? There's the ocean.
No.
Yep. That's the ocean. And then here's the boat. And then
What is it now?
this is the dock. And the
It's
dock
in-
means like the boat is tied here.
That's
Uh,
Excuse me. The dock
Yes.
only for the boats or even for the big ships? For the
Dock
big-
is usually, well, no, actually, it's usually for small and medium ships.
I
We
mean,
don't really say dock when it's a big ship, we usually say harbour.
Harbor.
Yeah. But I'm not 100% sure if that's always true.
I think so.
Yeah, but dock would be for small ships and harbour would be for big ships. And port would be for biggest. Yeah. Dock, harbour, port. I don't know if that's
That's
a hundred.
harbor port.
I don't know how true that is, but when we use these
Well,
words.
In Arabic it's the same actually.
Yeah, really?
Yeah,
Yeah,
it's
okay,
exactly the
okay.
same.
Dock, harbour and port. Yeah, okay. So what's happening here is we're told that the distance from here to here is 4 meters. And this boat is moving up and down. And how long does it take to move up and down?
Once per second.
Yeah, it says it's once per 2 seconds. So that means the t equals 2 seconds, which means the f equals 1/2 hertz. And this is the wavelength. You like my picture?
no.
That's great. I think this is my favourite picture I've ever drawn.
Why?
I don't know, just the details. I can add in some fish here as well. And some clouds.
Some nude people lying down there.
Well, how about we give them an ice cream? All right. So we want to calculate how fast these waves are moving. So the formula, V equals lambda f. So what's the wavelength here? 4. And the frequency? 1/2. So the answer is 2 meters per second. That's how fast the waves are propagating. So for example, if you look at the top of this wave, it'll go up and down to the right. The speed here is 2 meters per second. That's what my answer means. So if there was some like little fish on the top of this wave, then the fish would be floating across here 2 meters per second. Yeah. This is why in the question I said that the boat is tied. Because if the boat wasn't tied, it would move with the wave.
Yeah.
That's why I said it was tied. Actually, that's a work of art, that picture. Like, really is. I should sign it. Stephen 2015. Right, okay, so really for this lesson, there's only one new equation, which is this, called the wave equation.
You should do a picture of it.
I know it's going up on YouTube. We'll get 100 million likes. Okay. Yeah, so there's only, the questions are all quite similar. So there's 3 questions there anyways. You can take a picture of these. So there's not too much maths in this section on waves. So mechanics probably had the most maths in it. And electricity had a lot of maths in it as well. But waves doesn't have too much maths in it. And I think this is maybe why students don't like it in the exam. They prefer the questions with calculations. But I don't think these questions are too difficult once you understand them.
Yeah, sure.
Yeah. So what we'll do is, yeah, I need coffee. So I'm going to go to the canteen, and then when I come back, we'll do the next lesson. Okay. Yes. Well, did you take a picture of this if you want to do the questions, or is anybody actually going to do the questions now?
No.
No, I didn't think so. So I can turn this off then. Can you put the light back on, Yemi?